Okay, good afternoon, everyone. Just before we start again, just for your attendance, you'll need to rename your participant name so that it has your name and your student ID, right? Again, just in case if the tutorial, if this particular session does not complete within the next 40 minutes, then what will happen is that this session will end and then you have to rejoin using the same link, right? So like you guys have suggested, you guys wanted me to discuss regarding the secular convolution, right? So let's start with the secular convolutions. There's three methods. That is, the first one is the graph method. The other one is the normal definition method, right? Graph method and the definition method is practically the same. And then there is another method that is known as the, what do you say? It is the matrix method, right? So these three are the time domain convolution methods. The other one is the DFT method that I'm not going to touch on because I believe everyone should be knowing it's directly transforming the equation into DFT, right? So let's start. So let's say we have two sequence over here. That sequence one is just a set of four numbers that is 1, 2, 3, 4, and sequence two is another set of four numbers that is 5, 6, 7, 8, right? Why I've selected this sequence, it is because it is the most basic basic sequence that you can come up with, right? So I've just kept it as basic as possible, and you can apply this method to any length of series. Any series that you are given, any discrete series you are given, right? As long as when you are dealing with secular convolution, it is mostly with a periodic signal, isn't it? So in this particular case, so the first one is a graph method. So let's start with the graph method, right? So when we are graphing this, we assume it's a periodic, right? It's not necessary you have to draw all the points, but just noting down the initial points. So I've drawn the graph that is 1, 2, 3, 4. It is x1 of n, right? So x1 of n is 1, 2, 3, 4. So I've just plotted this, right? The first 4 points is the initial sequence, while the others are just periodic part, right? Isn't it? It's just a repetition just after the initial sequence. It's just a repetition of the sequence again. The same goes on the negative side, right? I haven't drawn on the negative side, but if you were to draw it on the negative side, it would have been like for this, there's 4 points. So over here, it would have been up till 4. Then 3, then 2, and 1. So you get the basic idea, right? It is just the set of these 4 numbers that are repeating itself, right? It's a periodic sequence, we can assume, right? So that's for this particular, just graphing this particular sequence, right? So that's one. Then you do the same for the second sequence, right? So you can just write it down, right? So I've just represented it with the continuity sign. That's just for the periodic part. So the initial sequence is just 1, 2, 3, 4. You can write it down, right? You can represent the whole graph into a sequence as well, right? So what I've done is I'm not going to continue drawing this same sequence. I'm just going to use the numbers to represent it, right? So in this particular case, 0 is our initial point, right? Okay, and 5 in this particular case. So those are my starting points. So, okay. So moving on, right? Once you have done with the sequence, what you'll need to do is to just you have the sequence, you have one of the sequence, the other sequence is given there. So the next thing is you have two sequence, you have to reverse either of the sequence, right? You have to flip it, isn't it? You flip it and then shift accordingly, isn't it? When you are graphing the sequence, right? When you are finding a convolution using the graph method or the definition method. So you keep one of the sequence as it is, with the other sequence you flip it, right? So basically, if we flip this particular sequence that is given as 5, 6, 7, 8, we'll flip and we'll give you 8, 7, 6, 5, right? And then if it was a periodic part, then again, it would have started from 8, 7, 6, 5, and so forth, right? So that is what I've done here, right? I've just directly written it down rather than graphing the same sequence again, right? So once you have flipped the sequence, what you do, you shift and you just multiply and add, isn't it, in the graph part, right? So initially, when you flip it, this 5, right? This 5 will come in line with the initial point, isn't it? Right? So that 5 comes in line with the initial point, right? And you can see that 5 is the end of this sequence. So the next point will be 8, 7, and 6, isn't it? When we are writing it, the sequence convolution of this. So I have written 5, and then I have written 8, 7, 6. Because after 5, this whole sequence will repeat itself, isn't it? This is the flipped sequence, isn't it? So after 5, it will be again 8, 7, 6, right? So each time when you are writing the sequence, it will be, since this is a of size n, right? Both the sequences are of size n. So your convolution points or your convoluted sequence will be also of size n, isn't it? So we'll be having four variables, isn't it, in that particular case to add as well. So in this particular case, we'll use the 4, right? The 4 periodic part. So 1, 2, 3, 4, right? We have flipped it. The flipped sequence, you write 5, and sequence ends over here. Then you go back 8, 7, 6. Basically, you get this part, right? You can draw it in the graph, or you can just write it down as a sequence, right? Because this whole thing will continue. You'll have a 8, you have a 7, you have a 6, you have a 5, right? This is the flipped part. While on the other side, again, it is 5, 6, 7, and 8, isn't it? Okay. So basically, are you getting the idea what I'm doing over here, right? It's basically shifting, flipping the graph and shifting, right? Are you getting what I mean, guys? Okay, great. So if you understand what I'm doing right now, right, and then this is just the most simple part, right? So basically, 1 is in line with 5, right? So 5 multiplied by 1 is going to give me 5 plus the summation product and summation of 1, right? Mute all. Yeah. Okay. Okay, great. So 5 multiplied by 1 is going to give me 5 plus 8 multiplied by 2 will going to give me 16. 7 multiplied by 3 is going to give me 21 plus 6 times 4 is going to give me 24. So the sum of that will give me y of 0 because my 0 is in line with 0, isn't it? So that is going to give me 66 in this particular case. So y of 0 is basically going to give me 66. Now, next one, in order to find my y of 1, what I'll need to do is take this 5 and shift it 1 unit this side, right? So that means 5 will come in line with 2, right? And then followed by 8 coming in line with 3 and 7 coming in line with 4. And then this 6 shifts out, right? So what happens is that 6 comes just in line with 1, right? So basically it's rotating in a circular motion, right? So you'll be ending up with this particular sequence, right? Y of 1, this is what you are going to get, right? So basically 5 has shifted 1 unit to your right, right? So 5, 8, 7, and then 6 comes right after it, right? Based on the sequence, you have 6 and then 5, right? 6, 5, and the remaining 2 digits are 8 and 7. So 6, 5, 8, and 7, right? Again, do the same procedure. 1 multiplied by 6, you're going to get 6, right? 5 multiplied by 2, you're going to get 10. 8 times 3, you're getting 24. 7 fours is 28, right? Sum it up, you're going to get 68, right? Then y of 2, what happens? You shift the initial sequence of 5 by 2 units, isn't it? So that 5 was initially over here. Now it has shifted 2 units, 1, 2, right? Just after 5, right? Just after 5, you go back and start with 8, isn't it? So that is what you are getting here, 8, right? 5, 8, and then the 7 and 6 comes in front, right? Okay. So based on this, it is basically just shifting, right? It is going to go in a circular motion, right? So you end up with 66 as y of 2. Same goes for y of 3, right? Do the same procedure. So you are left with y of 3 as 60, right? This is one way, right? This is one way of computing this particular what do you say? This is one way of computing the circular convolution, right? Then there's another method that is the formula or the definition method that we are used to, right? So we have a sequence 1, 2, 3, 4. We are using the same sequence so that we can verify that we are getting the same solution using all three methods, right? So we have the first sequence, again the same one. Second sequence is again same, 5, 6, 7, and 8, right? Please excuse me because I had to rewrite it because what happens is when you are using the formula, it becomes slightly tricky, right? So initially, the formula for finding circular convolution is given by this, right? So basically, x1 of k multiplied by x2 of n minus k into n, right? Summation of values from 0 till n minus 1, right? So if you need to find y of 0, in place of n, you substitute 0, isn't it? So y of 0, right? You start from 0, you go up till summation goes up till n minus 1, isn't it? So x1 of 0. So initially you start with k is equal to 0, right? Sorry. So k is equal to 0. So x1 of 0, x2 of your n value is 0, right? This is a k, right? This part is a k. Sorry about that. It's not clear, I think, right? But this is k, right? Where I'm highlighting. Okay. So x1 of 0, x2 of, in place of n will be 0, right? And k value is 0. Next is sum it, right? Add. Now the k value changes to 1. So x of 1, right? Times x of 2 into 0, right? N is 0 minus 1, right? And this 4 indicates modulus of this, right? Whatever you have, 0 minus 0, you have a 0, and modulus of modulus with that, right? Modulus of 4, whatever value you get will be the x2 of 0 value, right? Basically, you can ignore this 4, right? It's not that important after all, because whatever you are going to get, it is going to be within that limit, right? Between 0 and 3, right? So don't worry about this small 4. This is just a representation, right? So next part is when k equals 2, right? So plus when k is equal to 2, x1 of 2, x2 of 0, right? This n is 0 minus 2, right? And then close bracket plus x1 of 3 into x2. Remember, n is 0, so 0 minus 3, right? And you stop over there because our capital N or the size of the series are 4, or we are finding 4-point convolution, isn't it? So it goes up till from 0 till 3, from 0 up till 4 minus 1, that is equal to 3, right? From 0, you are going up till 3. Okay. So now you can see that x1 of, 0 of x1, right? x1 of 0 is given by 1, isn't it? So 1. x2, x2 of 0, x2 of 0 is 5, right? So that becomes, this particular term reduces down to 1 minus 5 or 5 minus 1, right? Either way. Then plus, right? Plus x1 of 1. So based on the series that we have, x1 of 1 is given by this particular value, isn't it? That is 2. So I write down 2 times x2 of -1, isn't it? So you are having a -1. So what happens? This is, let's say, you are going forward like this, right? So you're going from 0, 1, 2, 3, right? Isn't it? So negative is going backwards, right? So what happens is that this sequence is repeating itself. When you are doing a circular convolution, basically the whole sequence is in a circle, isn't it? So -1 is my 8th value, right? The 0 remains as it is. So 0, 1, 2, you are going like this. So it is positive, right? When you go backwards, your -1 is 8. So that's where I get my 8th value, right? You do the same for the next two terms, right? You get 3 times 7 plus 4 times 6. You can see that I'm getting again 5, 16, 21, and 24. The sum of that is going to give me 66, right? If you compare this to the graph method, the initial graph method, you can see that the calculation is same with the graph method as well, right? The definition method is giving me the same summation and same value for y of 0, right? I'm getting 66 in both the cases, right? So that proves that this the formula of graph, the definition method and the graph method are pretty much equivalent, right? If I had to represent this, like I said, I just went the other way around, right? If I draw a circle of this, right? And let's say if I draw a circle of this, you might have landed in the circular motion part, right? You are starting from x of 0, right? Isn't it? You can keep this into a circle. This whole sequence is basically going in a circular fashion, right? If it's a periodic, it goes in a circular fashion, isn't it? So let's say this initial point is your x of 0. Next point, since it's 4 points, so we divide the circle. Right? This is the initial starting point, let's say. And we divide the circle into 4 pieces. So this is the second point, this is the third point, right? And this is the fourth point, right? So this the first one is my x of 0. Okay. The next will be x of 1. The next is x of 2. And then this point is x of 3, right? If I'm going clockwise, right? Or if I'm going in the forward direction. So if I say x of 0, this is my first point. If I'm saying x2 of 1, so this is my second point. This is my third point, and this is my fourth point. So it is basically going in clockwise, isn't it? So if I had to find my x of -1, what happens is you are going in the opposite direction, isn't it? You go in this direction. So you can see that x of 3 is also equivalent to x of -1, right? So basically the value that we had over here, remember, x2 of -1, I said it is equivalent to 8. So if we put these values over here, you can see x of 3 is equal to x of -1. So x of -1 in this particular case is also equivalent to x of 3, right? So it is going to give me a value of 8. That is why I substituted 8, right? So that's how you get this particular point, right? Just another trick, right? There's another trick to this. If you are having a negative value, right? If you are getting x2 of negative value, what you do, whatever negative value you have, you add the capital N value, right? So in this particular case, my capital N value is 4. So if I'm getting -1, you just add 4 to it. So -1 plus 4 is going to give me 3. So basically x2 of -1 is also equivalent to x2 of 3, isn't it? You get what I mean? This is just another shortcut to this, right? Are you guys getting this? Okay. Set. So likewise, we do for the other ones, right? I'll send you this whole PDF, right? This whole working that I've just done. I'll send it over. I think I'll just send it in the message right now so that you have a copy of it. Just give me a second. Okay, this is a copy of it, right? Just check your message section just in about 5 or 10 minutes, right? Meanwhile, I'll just continue with the discussion, right? With the same part, you go with y of 1. Again, you start from 0, you go up till n minus 1. So in this particular case, my capital N is the size of the sequences, isn't it? So in that particular case, that is equivalent to 4 over here. So 4 minus 1, it is 3, right? So you are basically getting summing it up from k is equal to 0 till 3. So you start with k is equal to 0, right? Again, x1 of 0, x2 of, in this particular case, my n is 1 minus k value is 0. with a modulo of 4, right? So this 4 is basically indicating it's a what do you say? It's a periodic signal, right? Of 4 points, right? So plus again x1 of 1, x2 of 1 minus 1, right? Again, you continue substituting, you'll get this particular part, and it reduces down to x1 of 0, x2 of 1, right? This the first term, x1 of 0, x2 of 1, plus x1 of 1, x2 of 0, because 1 minus 1 is 0, plus x1 of 2 times x2 of -1. Again, we are getting a negative value. What do? You can refer to the graph, you can refer to the secular part, whatever you find is easy for you. But I'd always suggest, if you are getting a negative value, just add the capital N value. So the capital N value over here, it is equivalent to 4. So we are having a -1. So add 4 to it. So that will give me x2 of 3, right? x2 of -1 is basically equal to x2 of 3. Same goes for the next terms, right? Again, you can see for y1, it reduces down to x1 of 0 is 1, x2 of 1, right? x2 of 1 from this particular series, it is 6, right? 1 times 6 plus x1 of 1 times x2 of 0, isn't it? So x1 of 1 is 2, x2 of 0 is 5. So 2 times 5. Then third term is x2 of 2 times x2 of -1. So basically this x2 of -1 is equivalent to x2 of 3, right? So x1 of 2 is, from this particular point, it is 3, right? So 3 times x2 of -1, which is also equivalent to x2 of 3. So x2 of 3 is 8. So 3 times 8. x1 of 3 from the sequence, it is 4, right? So we have 4 times x2 of -2, right? Again, we have a negative value, so plus the capital N. So the capital N in this particular case is 4. So 4 plus -2 is going to give me 2. So x2 of -2 is basically equivalent to x2 of 2, right? So in this particular case, it is going to give me 7. So 4 times 7. Again, simplify this, you are going to get 6 plus 10 plus 24 plus 28. It is going to give me 68. Now, referring back to the graph method, what do we have? 6 plus 10 plus 24 plus 28, right? Keep that in mind. Going back to the graph, we have 6 plus 10 plus 24 plus 28. Again, we are getting the same values, isn't it? When we are adding in both the cases. And that sum gives me 68. Y1, y of 1 is going to give me 68. From the formula method, I'm getting 68. Likewise, you do it for y2 and y3, we are going to get 66 and 60. Going back to the graph method, we are getting 66 and 60, right? So basically, the graph method and the formula method are giving me the same result, right? So that verifies both the methods are going to work. So whichever you find it easy, you can use it. I would suggest you use the graph method. This can be also, when you are using the graph method, this is also considered as the definition method, right? In the graph method, you are visualizing, or you're literally understanding what is going on, while in the formula method, you are just directly substituting whatever value you are getting, right? So that's regarding these two methods, right? I hope you understood this too. Have you guys understood this too? These two methods? Okay. Now the next method is the next method, right? That was for the definition method, right? The next method is the matrix method, right? So all this while over here, you can see that in the first part, we transformed, we flipped x2 of 2, right? And then we shifted x2 of n, right? Isn't sorry, what I'm saying. I meant is that x2 of n, we flipped x2 of n, isn't it? And then we shifted in the graph method, right? The same goes with the formula method. In this particular case, we flipped based on the formula, we flipped x2 of n and then we shifted x2 of n, isn't it? While we kept x1 of n constant or as it is, right? We did not shift x1 of n, right? In both the cases. So when you are doing the matrix form, you have to select, right? Which what do you say? Which sequence you want to flip, right? Which signal we want to flip, and based on that particular signal, that is going to shift. So all this while we were flipping x2 of n, isn't it? So let's keep that, right? So if we are flipping x2 of n, right? Let's keep it as it is, right? We were flipping x2 of n all this while. We'll flip x2 of n in order to find the convolution of those two signals, right? These two signals. So what you need to do is you start by writing the sequence. The first column will have the sequence itself, right? So we are flipping x2 of n, so we'll have a n by n matrix. So the sequence we are flipping will form this n by n matrix, right? Whichever signal we are flipping. So all this while we are flipping x2 of n, so we'll flip that, right? We'll keep it as it is. So the first column will have x2 of n, so that is 5, 6, 7, and 8, right? As it is. You write it in the column form. Now we are ending at 8, isn't it? If we are ending at 8, you take that 8, you write it, you start with that particular number with the second column. So we are ending with 8, we start the next column with 8. So 8, so if it's a periodic signal, this whole signal repeats itself after 8, isn't it? So it will repeat it after itself. So we have 5, 6, 7, and 8 repeating, isn't it? So what happens? What happens is you're starting with 8. So the next number will be 5, 6, 7, isn't it? So 8, 5, 6, 7. Okay. Or you can say you are ending with 8. You go back and you start with 5, isn't it? So we have entered this first column with 8. We go back and start with 5. 8. And then the next time will be 5, 6, and 7. 5, 6, and 7. So we stop at 7, right? Because each column we are having an n by n matrix. So the number of rows we'll be having is 4. So we'll have four digits, right? So the first one will be the last one of this column that will be transferred up over here, that is 8. So next one is 5, 6, 7. So we are ending with 7. Again, we go start with 7, right? The next digit is 8. After 7, it's 8. And then you go back and start with 5 and 6, or you can directly rewrite the same sequence. And based on this, you can extract the next 4 digits. So if we are starting with 7, next digit is 8, 5, and 6. 7, 8, 5, and 6. So we are ending with 6. The next column will start with 6, right? So if we are starting with 6, 6, 7, 8, and 5, right? Based on that, we'll continue doing it until we have an n by n matrix. So the n in this particular case is 4. So we'll have a 4 by 4 matrix, right? So all of you are clear how we get this particular matrix now? Okay, great. So just in case, remember in last week's tutorial, right? We had one of the sequence, we did not have one of the sequence while we have the convoluted part, right? So based on that same part, we can directly keep one of these matrix unknown and we can solve the matrix, right? So based on this, it was working, right? So we have determined the first sequence, right? This is for the sequence that we are willing to flip, right? And the next sequence, we keep it as it is, right? So we have to, in this particular case, we have chosen that x2 of n will be flipped. So that is why we have came up with the n by n matrix for that particular case. And x1 of n, we have 1, 2, 3, and 4, right? As it is. As it is, you write it in a column form, right? In order to compute y of n, you just multiply. So all of you know how to do the matrix part, right? Isn't it? So 5 times 1 is going to give me 5, plus 8 times 2 is going to give me 16. 7 times 3 is going to give me 21. 6 times 4 is going to give me 24, right? So that's how you get this first term, right? I mean the algebraic equation for the first term of y of n, that would be y of 0, right? So summing that up is going to give me 64. I mean 66, right? So going back to the graphical method and the to the definition method, you can see the first term is 66, right? Y of 0 is going to give me 66. That is basically sum of 5, 16, and 21. 5, 16, 21, and 24. So if you go back, right? If you go back, you can see that Y of 0 is the sum of 5, 16, 21, and 24. That is going to give me 66. Next two terms are 68, 66, and 60. So likewise, you are getting those terms, right? So that's how you get the convolution using a matrix method, right? Okay. The other thing is, as you know, the matrix method is commutative, right? Isn't it? So I mean, not the matrix method. What I mean is the convolution is commutative. So that means x1 times x2 is equal to x2 times x1, right? Convoluted either way, right? Isn't it? So likewise, if we flip x1 of n and keep x2 of n as it is, right, you're going to end up with the same convolution. Is that right? All right. That's how you compute the convolution using the matrix method and the matrix method, the graphical method, and the what do you say, the definition method, right? So all of you get this? Okay, great. So there's one more thing that I'll need to teach. I mean, this is regarding the circular convolution. So we have covered about circular convolution. If you have trouble finding this, I have sent the file in your in the chat box, right? You can retrieve this file and just follow through what is being done there. I think you will find it easy, right? There's another thing that I'll have to tell you. So if right, at times you're going to get a two sequence of size. Okay, let's consider just before I move on. Let's just consider. Okay, that's what I'm going to tell you, right? Just in case if the lengths are not same, right? Let's say if what happens is, let me annotate it. If the lengths are not equal, let's say if we had x1 of n as 1, 2, and 3, there was no 4, right? We just had 1, 2, and 3, while x2 of n was just 5, 6, 7, and 8. And we were told to find 4-point circular convolution. So what you do is the sequence that is short of a digit, right? So we paired it with 0, right? We add 0. So let's say if the sequence was 1, 2, and 3, there's no other digit after this. The size of this was of 3s, right? The second sequence was of size 4, and we need to find 4-point circular convolution. So we increase the length of the shorter series to 4, right? Either way, we paired it with 0, right? If the sequence is short, we paired it with 0. If the sequence is, let's say, large, right? If we had a sequence that was large, and we had told to use find a 4-point convolution. Let's say if this was of length 5. So what we do, we'll just consider the first 4 sequence, the first 4 digits, right? Is that fine? All of you are okay with this? Please take note of this, right? So if the sequence is short, right? If one of the series are short, you pair it with zeros, right? You add that many number of zeros that it is short of, okay? If the sequence is more, you truncate it, right? Is that fine? Now, there's another thing. Let's say we consider x1 of n as size L, right? Like I said, it's not of equal length. Let's consider x1 of n as L, x2 of L as P, right? So both are of different sizes, isn't it? Like you questioned me. How do you go about doing this, right? So we consider x1 of n as size L, while x2 of n of size P, right? So what happens is if you go over here, right? Let me clear the annotation window, right? So it says, please take screenshot of this. This is really important. If you can find this note, then that is fine, right? It says that a sequence of secular convolution property is that secular convolution in time domain can be computed efficiently by multiplication in Fourier domain, right? All of you are familiar with this, right? So secular convolution in time domain is equivalent to multiplication in Fourier domain, or multiplication of DFT, right? Okay. So that first point is clear. Second point, if two discrete sequences of length L and P respectively are zero padded to length N, such that N is greater than equal to L plus P minus 1, then the secular convolution of the sequences is equal to the linear convolution of the sequences, right? What that means is going back over here, going back to this particular part, right? So what happens is, okay, just before I start explaining the other part, please rejoin this session using the same link, because we are running out of time, right? I'm ending this session right now. Please join back again. Is that fine? Okay. Okay, thank you for understanding. So I'll end this session over here. Please rejoin again right now, just within a couple of minutes. We'll continue from where we are stopping, right?